All right, so for the sodium metal reacting with oxygen, first of all, what we'll do is we will write out the equation. So we've got sodium solid plus oxygen, which we're told is a gas, and that's going to go to sodium oxide. So first thing we need to do is we need to get this formula here correct, the chemical formula for sodium oxide, and then we need to balance the equation. So Na, we know that's in the first column, so that goes to Na plus, or 1 plus, because it's got one outer shell electron. And oxygen, which is in group 16, or columns, it's 2, 6. It goes to O2 minus, because it'll pick up 2 electrons to get the full outer shell. So clearly we're going to need this times 2 to neutralize this, and so we're going to get Na2O. All right, so first of all, let's balance, so that now we've got the formula for the product, let's balance the equation. So we'll have a look at each one from left to right. So we've got 1 sodium here, got 2 sodiums here. So let's put a 2 there, that's fine. So now 2 sodiums, 2 sodiums. Now I've got 2 oxygens here and only 1 oxygen here, so I have to double this. And as soon as I've made a change, I have to go back to the start and go through it all again. So here 2 sodiums, 4 sodiums. So now we change this to a 4. And then we start again. 4 sodiums, 4 sodiums, 2 oxygens, 2 oxygens. We're all good. So we've got a balanced equation now. Now we're told that 20 grams of this is going to be burned in excess. So we've got heaps of oxygen. No need to worry about the mass or the quantity of oxygen. And we're asked to find the mass of this. Oh, and we're also asked for the mass of this as well. Okay, all right, no worries. Now, the important thing here is the mass that we've got is this one here, and that will allow us to find the number of mole here. Now, the ratio of this is going to be 4 of those produces 1 of those, so I'm going to take that number and I'm going to divide it by 4 to get this one here. This is a 4, a 1, and this is a 2, so I'm going to take this number of mole and divide it by 2 to get this number of mole here. Anyway, we'll get to that in a bit. So first things we want to do is just get the number of mole on this side here. So we know that number of mole is mass divided by molar mass, and so number of mole is 20 grams divided by, let's have a look in the periodic table for sodium, 23, I think. Yep, 23. 23 grams per mole. And so the mass units cancel out, and I've got 1 over mole to produce mole as my unit. It's always good to include units. You don't lose that mark on the exam. So go 20 divided by 23, and we get 0.87. Now, I would be encouraging you at this point to use the memory function on the calculator and not round this off. It's a 0.86956, blah, blah, blah. It just goes on. If you round here, then your answer is going to be slightly off because you'll probably have to round your answer again anyway. So try out to the memory function on the calculator and just write here a rounded value, but in your actual calculations use the exact value from the calculator or the given value from the calculator. All right, now we know that if the number of mole, if we need 4 of these for 1 of these, then what I'm going to get here, the number of mole for this is going to be 0.87 divided by 4 there. And here the number of mole, which is the same as timesing by a quarter. And here the number of mole is going to be 0.87 divided by 2, which is the same as timesing it by 2 over 4. So what I'm doing is I'm using the ratio of the numbers here and here to produce the fraction or the thing that I'm dividing by. All right, so let's go for capital M first. Here is 32 grams per mole. And let's do this one first. And so M equals N times big M. M equals divided by 4 equals 0.22. See, I'm using the values on the calculator now, times 32, and that's mole. Nearly forgot my units, grams per mole. And so mass here is equal to, times that by 32, equals 6.96. Now, if I round that, I can round that now because I've got my final answer there. All right, now let's do the same with this one here. So we've got number of mole here is divide that by 2, 0.43 mole, which it's actually 0.43478 because I'm using the 20 over 23 for the number of mole. I'm just writing this rounded number here because I don't want to write an infinite string of digits because I'll spend the rest of my life doing it, and I've really got better things to do. So this is the number of mole of this that's produced. Now we need the molar mass for this, which is Na2O, which is 23 plus 23 plus 16, 2 sodiums, 1 oxygen, and so the molar mass is 4656.62 grams per mole. And so again, M equals N times big M. M equals 0.43 mole times 62 grams per mole. And so mass equals, just put the wrong number into the calculator, 26.96. Yeah, so let's have a look at that. That's we've got our two answers. We've got the mass of sodium oxide that's produced there. We've got the mass of oxygen that was used. And interestingly here, this makes sense. If I have a look at this, check this out. I've got the mass of sodium plus the mass of oxygen equals the mass of sodium oxide, which really shouldn't be a surprise, but that was a nice little thing to see there. All right, now just hang on a sec. All right,